So hello, today I will be showing you how to easily take a derivative. So we can start off with this simple derivative rule, where if we have x to the power of n, we can simply bring down n, turn it into a coefficient, and then for the exponent, we just subtract 1 to get the derivative. So if we have something like f of x is equal to x to the power of 3, by following this rule, we can simply bring down the exponent and turn it into a coefficient to get 3, have x remain the same, and then subtract 1 from the exponent. 3 minus 1 is 2, so we just have 3x squared as our derivative. But what if there's a coefficient in front of the x to the power of n? Well, in order to find the derivative, we can use this same principle and move n down into a coefficient and multiply it by the original coefficient that was there. And we can resume with taking 1 away from the exponent. If we have something like 5x to the power of 3, well, to find the derivative, we can simply bring 3 down onto the coefficients and multiply it by the coefficient that was already there. So 3 times 5 is 15. We have x, and then we subtract 1 from the exponent to get 15x squared as our derivative. But what if it's just f of x is equal to x with a coefficient? Well, this is equivalent to having a of x to the power of 1. In this case, if we want to find the derivative of this, we can follow the same principle from earlier, and we can bring down 1 to have a times x, and then subtract 1 away from the exponent. This would leave us, theoretically, with a times x to the power of 0. However, anything to the power of 0 becomes 1, and so this is essentially just a times 1, and this is equivalent to just a. So if there's if there is an exponent of 1, then the derivative just becomes the coefficient. But what if there is no x? What if it's just f of x is equal to a number? Well, this means the derivative is just 0. And well, the theory behind this is if it's just a number, then it's equivalent to ax to the power of 0. And if we try and take the derivative of that, we get something like a times 0 to the power of x, or times x to the power of minus 1. And anything multiplied by 0 just becomes 0, so we would get 0x minus 1, and whatever x to the power of minus 1 is, we would multiply by 0, and it would just equal 0. So let's put these into actual practice problems. So firstly, for f of x, we can use the principles we just learned, and we can take the exponent and move it down to the coefficients. We can multiply it by the coefficient that is already there, which is 4, and we would get 20x. And then we would subtract 1 from the exponent to get an exponent of 4. And we can repeat this for the next terms. 3x to the power of 4. 4 times 3 is 12. 4 minus 1 is 3. Minus 3 times 2 is minus 6. 2 minus 1 is just 1, and a coefficient of 1, we can just not include it. It's just minus 6x. Oh. And for 9x, well, the derivative of 9x just becomes the value of the coefficient, which is 9. Moving on to g of x, we want to find the derivative, the first part is just the same. 3 times 3 is 9. 3 minus 1 is 2. 4 times 2 is 8. And 2 minus 1 is just 1, so we don't include the 1 in the exponent. Minus 7x just becomes minus 7 because it stays as the derivative is just the coefficient. And plus 15 becomes plus 0 because there is no x value. And so plus 0, we don't need to include this in the final answer. But what about h of x? It's in a different format than what we originally learned. So we need to turn this into the same format to find the derivative. We can simply just multiply these two, and we would get 2x times x is 2x squared. 2x times minus 3 is minus 6x. Plus 5 times x is plus 5x. Plus 5 times minus 3 is minus 15. And we can simply equate this to 2x squared minus x plus, or no, not plus, minus x minus 15. And if we try to take the derivative of this, we would just use the same rules that we learned earlier to get 4x minus 1. And that is because here for the term minus x is just minus 1x. And so the coefficient just becomes the derivative. But what about for a of x? We can't turn this into the same format. Well, we actually can. And the way you would do this is because the square root of anything is just that value to the power of half. So the square root of x, well, that just equals to x to the power of 1 over 2. And for finding the derivative, we can just follow the same rules. We can bring this 1 over 2 down to get a coefficient of 1 over 2, x, and then 1 over 2 minus 1 is just minus 1 over 2. And that is our final answer. The derivative of the square root of x is just half of x to the power of minus half.